Yes, thank you very much. It's a bit funny to play foreigner in Finland, where I worked for 12 years, but so is life. Yes, I'm sorry that I'm not able, still after 12 years, to present scientific stuff in Finnish, so let's suffer through some English together. It was Donald Hoburn who was supposed to be talking here, not me, but he's busy now presenting similar things in Cape Town to the whole African continent. Happy International Biodiversity Day. 22nd of May is a very difficult day to find kind of people outside work who are busy with biodiversity data. This is our holiday, that's why we're having here today. I will try to present three things here. The overview of global biodiversity data, what GBF is doing in this respect, and what's Finland's role in the global play. The knowledge pyramid, I think it's very much over-presented figure, but apparently, as with any complex enough field, there is a lot of terminology mess. We talk about data, information, knowledge, wisdom, and so on, and it's sort of intuitive, but nobody really knows what it's all about. One more slide on what's biodiversity data. I think everybody in this room knows very well that it's very complex matter. There are objects, there are images about them, there are sequences around, there are a zillion of names, well and poorly synonymized and resolved, depends on the research interest for the group. Some ecology information, numbers, maps, and things like that are flying around and end up in research papers and reports, in decision-making documents. There are various sources of that. We all know that it comes from the collections, like museums, field observations, from laymen and from the professional communities. There are several regional and global attempts to do the repeated surveys, to do the monitoring, and if we go along the timeline, there are various attempts to reconstruct the past, to predict the future, and so on and so on. And then there are certain uses for this data, and until now, globally and at the country levels also, the information is collected and often used once. That's the default. That's what you learn as a student. That's how things have been so far until very recently. If you need the data to answer your research question, if you have research budget, or you can go yourself, you go and collect, or you send your student, or you hire a research assistant, or you order a survey if you work in Metsähallitus, and then your nature reserve is explored. Here you go, you have the report. It goes somewhere, gets used, and that's the old way of the data storing. Now, in recent decades, it's been changing. So the data use and data reuse is going to be an increasing trend, and there is a lot of mentality change for people who used to work in the old way, like question-driven research and demand-driven management surveys. Of course, should reuse the data available so far and try to complement what we know already with some gap-filling activities. Connecting the complexity of biodiversity data bits is a very challenging task. As we heard this morning, it's challenging enough to do it at the national level, and at the global level, the scale of mess and technical incompatibility increases a lot. But it's all in human minds, I believe, and the evidence, the understanding, the data, it really depends on the data culture, if you want, and it varies a lot. It varies between institutions, it varies between countries, and if we go west, we end up in Sweden, where data culture is very strong, and Finland is very actively moving in the same direction. If you go east to Russia, then it's the country where I come from, you will find quite a different story about who owns the data, whose collections, and so on we find. If we continue with this level things, the sources of data, they come, as I said, from various sources. Usually there is a particular goal, a doctoral thesis, a nature reserve survey, invasive species assessment, and things like that. There is a question that must be answered, and data are collected to answer that. It ends up in various formats. Luckily, more and more people collect and format and store the data digitally, but not always there. And there are various international organizations who help to collect and aggregate data at a global level. GBIF is working with the occurrence data and checklist, catalog of life, mainly with names, there is trade bank, and so on. If you aggregate the data at any level, it's doomed to be heterogeneous. It will, no matter how hard you try to format it and tell everyone that's the way to collect it, if it comes from various sources, it will be in need of some processing and some compatibility work to put it together in a single resource. And the other global component and important component at any scale is that biodiversity data will always be gappy. We'll never be able to cover any surface, the planet or the island in the Baltic Sea, with thick enough network of dots on the time and spatial scale to say that now it's complete. It's never complete. There are always gaps, and they can be filled through modeling. And there are various communities, practice and research oriented, who turn the dots into surfaces, trying to draw the best possible image with no gaps. Research, fundamental and applied, is of course very much dependent on data, and this is the obvious thing. To support your conclusions, you need some material. And then these kind of evidences, they are collected and interpreted through networks of experts. You don't necessarily need a machine. If you have a smart enough expert or a group of experts, you can form something like mind, and you ask your people, please tell us what's right for this particular taxonomic group, for this particular moment. And you get a very good, very high quality result, but it's very much expert dependent approach. And the transparency is of course missing unless you combine data and experts, which is the best scenario. At the international level, there are various conventions and panels who are getting together and trying to figure out how the published data, how the scientific publications and the data, which are not yet in the publications, can tell what's going on the planet and what to do at the regional and at the global level. IBES, International Panel for Biodiversity and Ecosystem Services, is an attempt to follow panel on climate change. Both these panels work as enormous groups of experts who try to process thick piles of published data and raw data into some image and assessment that can inform governments and intergovernmental decision making. And then at a very high level, there are things like convention on biodiversity and all kind of biodiversity conventions. There are 7 main conventions at the moment, and CBD is the most influential. Yeah, and we all hope that national governments are listening to that, but of course it varies a lot. So GBIF is one of the big players in this game, and there are some logos here on this slide to show you who are the people who work most. So what happens if you actually go to the Global Biodiversity Information Facility portal? You see something very green, some numbers, some search boxes, and it's a discovery portal that makes publishers from different countries, from different institutions release the data, which are then open and available to all. Historically, GBIF was founded as a scientific infrastructure. It was supposed to channel the museum information into a single portal where it's available to museum-based research. In the course of its evolution, as I learned working there for about half a year now, it got increasingly politicized. It's very much respected and used by these intergovernmental panels and conventions, and research relevance is not lost, but the suitability for researchers to go to the portal and get the data and then do some analysis is far from perfect. That's what I'm trying to change while working there. And of course, there is a huge body of literature. Only a small portion of biodiversity literature is digitized, and so we need to work on that. A big new thing coming is that so far, GBIF data is presence-only data, and data coming from research projects and data needed for research projects is often sample-based. We need to know the time spent for a particular survey. We need to know what kind of square was surveyed before we end up with a certain list of species and abundances. And then we also need to know the taxonomic target. How many species you knew when you entered the forest, out of which how many species you actually found. This way we'll try to move from present data to something more rich and more ecologically useful. At the moment, there are about 500 million occurrence records available on the planet. And of course there is much more still hidden in collections, literature, citizen science projects, and so on. And that's how it looks like. This is the most recent map of global biodiversity occurrences. As you can see, this map doesn't tell you a very strong biological story. It's a map of biodiversity data activity, not the map of global biodiversity. And there are a lot of challenges in certain regions about opening biodiversity data, but I think it's a happy observation to see that Finland is shining. Despite all the gaps, the number of records, the amount of biodiversity data available globally is going up and up. And economical crises and regional and national troubles doesn't stop this. It is growing and it will keep growing. And the number of institutions which are interested in doing that, in opening their data, is growing as well. What happens to all that? There is gbif.org sitting somewhere in the internet. Who goes there and why? This is a split up from April 2015, April this year, about visits to gbif.org. It's not a very good way to see, but there is one way, is just to count the visits to the website. And so far US is the major visitor of the portal, and other countries follow. Downloading the data is a more serious thing. It's a signal for us that people are actually up to something. It doesn't guarantee that the data will be used in a publication or in assessment, but it's a next step. And here, Mexico, US, China, Denmark, and Brazil are in top 5. Still on the next level, the data end up in peer-reviewed publication. The current speed of publication is about 1 peer-review paper a day using GBIF data, and it's speeding up. The GBIF data are not for children. If you go there, download data, try to do some quick analysis in R, you will end up in a very weird distribution map, in a very strange prediction. And that's a common start for any GBIF-based presentation. It's fashionable to complain about imperfections of GBIF data. But as I said, it's heterogeneous, it's gappy by its nature, so some data post-processing must be done there. And some people are very good at that, and especially in distribution modeling and fields like this. Here are a few examples about the scientific uses of data from last month. And fundamental and applied, especially applied research, is dependent on the globally aggregated data. Many of fundamental questions can be answered by explorative or experimental studies at a very small scale. You need a case system. You study this hard, and then you get a theory or a local answer to a question which you're very happy with. But certain questions like invasive species, global health, global food, it is impossible to close the doors and windows and just concentrate on the inside country data. It just doesn't work. There was a question I understood about how do you credit those who do that. Why a busy researcher or a busy decision maker should open the data? And is it a charity? Is it just a good practice? Are we all just nice people doing that? Or is it actually something of a important practice that should be there for data and information flow to work? I would like to compare this to literature. I haven't heard people complaining about the need to cite works of others. Citing literature is so natural practice of any research or decision-making process that you just enter your references without thinking. Manually, using EndNote, Mendeley, you just do that. It's a tradition to be very transparent about what is your conclusion and what's the words that said somebody else. It's not the case with the data yet. Good papers have supplementary materials with rich tables of raw data before the analysis was made, before you came to the conclusions, but not all. And if you compare this to the taxonomy, if you skip the data citation, it's about the same bad thing as while describing the species, you don't tell where your types are. And that's not a good thing to do. In papers, to discover the paper, to cite it in an easy way so the computer and computer user can find it easily, there is a DOI, a digitally object identifier. It's a hyperlink sort of digital reference. We will try to use the same for the data. I show you a picture what is going on now with that. When a user downloads GBIF data, it gets a DOI assigned to this download. As I said, GBIF data is not for children. They should be processed, clean, filtered, and so on. And the data you use for the analysis, for your R script, for your statistical package, they get another DOI. So you can actually put both into your materials and methods, whatever you do, science, management, decision making. And this way the transparency improves. And it is improving on several levels. So the researcher, the reader, the publisher finds a possibility to track, to credit the original publisher. And I think that's what should happen. This is how it looks like. You can play with that yourself. At the moment, any download will get a DOI. Some journals actually provide the possibility to open the data behind the publication immediately to the global portals. I know that in Lomos there are several editors of biodiversity data journal. I think I skip this and move straight to how Finland is doing at the moment. So there are about 20 million records about Finland, provided mostly by Finland itself, but also by 32 other countries. What happens now? Yes, and data coming from Finland are coming about Finland itself, of course, but also about other countries. 123 in total. And that's the situation with pretty much any country where the research is strong. You publish about yourself and publish about neighbors, and this way the global data are accumulated. The data are growing here, and that's really good. Number of species occurrences is also increased up to 2012, and now it's going fairly flat now. I know that you have 35 minutes at the Finnish portal, and it's 20 available through GBIF, so there is apparently some disconnect, and we'll find out why. How Finland is doing at a global scale? Well, this is not a hockey championship chart, but it's a very solid 6th place if you look at the number of records published and the total number of records. I mean, from last month and from whole history of GBIF, and this is very, very good result. As a typical biologist, I don't know how to count, but I know how to divide one number by another. And what I did, I tried to calculate the per capita record score for a few countries. Here I have my notes. So it's 5.4 records per person in Sweden, which is globally #1 per capita country, and it's 3.7 in Finland. Okay, this sounds a bit like hockey championship, but it's 0.65 in USA. 0.65 in USA, which is globally top country in terms of data publishing, and it's 3.4 less than in Finland in very well-funded Artsdatabank in Norway. So if all 35 million records available for Finland are released, Finland will go to the very firm first place with 6.4 records per person. And I think that's what will happen. There are some challenges ahead, of course, but I'm sure that now the future for Lajitietokeskus looks really, really good, and let's continue working on these things together.